Good morning, everybody. So we're going to look at a few things from a slightly different angle this morning. I'm going to share my screen. And though the title talks about the enterprise platform, I will not talk about the enterprise platform. Just a little bit. Just a little bit. I am rather going to do it in an indirect way. And we're going to start with just a very brief reminder of some of the, I think, important items that we touched upon in the past couple of days. And in particular, the idea of a workflow. And what I said and repeated and bored you with for all these times that I stepped up here is these workflows are meant to create documents. Documents which are not just your average everyday drawings, but documents which are specific for a task. And the task is to inform somebody of something, especially because we want that somebody to react if there is a reaction that has to take place. And that is the concept of the author. And because I have the enterprise platform, I can create thousands and thousands of specific documents, bespoke documents for whoever my partners are going to be. And more particularly, I identify the two workflows of the work in progress, which means that, remember the swarm, everybody sees a little piece, but all these little pieces of the big picture together make the big picture, and so let's share the big picture backwards with all of the people who otherwise would only see a little piece and perhaps miss out on some very fundamental information. And particularly, the overall process, so the company might miss out on their reaction, on their take on things. And I finished my last presentation yesterday with this slide of an idea of a workflow. And it's an idea because, in fact, the number of possible workflows is infinite. And there is not a manual to create a workflow because they're all different. And they're all specific to each organization, to each consumer, to each author, to each day. Somebody asks us something, well, let's create a document specifically for that. Enterprise Platform is going to get busy and republish it and re-update it. But I brought this slide back because in this slide, I'm very explicit about mixing sources. We've heard from several people the idea of the single source of truth. You heard from me that does not mean to create a mega database, but rather a distributed Wikipedia, as long as we have one instance of each truth, and we know where it is, so we can make it available through various automations and mechanisms, not least the digital hub. Then we get all these digital twins, and we can combine them to create a digital twin for every individual author. And I decided that some of the questions that I've had in these days and the conversations that we had over the past time, because this is something that I've been chasing after for quite a while, I decided that I would actually show you an example, rather than just talking about it, show you an example of mixing and matching all of these different sources, individual sources and truth, and also to discuss a little bit what is the best way to exploit them, what is the best way to make them all available. And I picked, because this is what we talked about in these days, I picked examples from Rhino, Express Marine, which we have seen, Revit, Inventor, and so on and so forth. And I'll take this opportunity to briefly also introduce our latest sponsor, which is SmartShape, who just arrived this morning. And they do a collaborative engineering, portable mobile engineering review environment. The presentation is after lunch, but Jean-Marc, if you would identify yourself. This is Jean-Marc Leroux. So because you will see his presentation after lunch, maybe worth having a word with him during lunch, and he can tell you more about the SmartShape solution. So there are various strategies, but obviously Today, the automation part of whatever strategy we want to implement is going to be the enterprise platform. So we want to create a situation where I can actually use other software, I can use the output from other software within the ShipConstructor environment. And this brings up a slightly parallel topic, which is going back to the previous slide, which tool to use when. And the answer to the question is really which tool to use for what. It's not when in time, but it is what is the purpose that we're trying to accomplish. And a very easy example is the Express Marine structure, which, yes, with Genesis, we transform it into ShipConstructor parts. Before Genesis, which is going to take a little bit longer, a few months perhaps, a few weeks, a few months. But before Genesis, we don't have to wait for that. We have it. Let's use it. And what can we use it for? And in this slide, it's a very good example of that example, which is to say, if in a few hours, in a day, a couple of days maximum, I can generate the complete structural model of my ship or my yacht in a parametric way, which is very responsive to change, very, very responsive to change in the hull shape. Stefan will show us a bit more of Express Marine after me, saying, I'm going to use, for example, the Orca 3D tools, which many of you have, to change the shape of my hull. The structure is going to respond. What am I going to do with it in ShipConstructor when I am already modeling my system? Well, thank you, I have the structure, which allows me to create my volumes, or my rooms, as they're called sometimes, inside which I put my systems. And now I can do clash detection. Well, not with AutoCAD or ShipConstructor, but I can do my clash detection with Navisworks. Navisworks will clash surface models with solids, with lines, and you do a soft clash with point clouds. So the what for? The what for is that now in Rhino, which we all use for a million different things, I have a structure model which is immediately used by my ShipConstructor crew to do a formal, database-centric, extremely important systems model. Extremely important because I'm now getting also my bill of materials, my quantities, my reports, my arrangement drawings. We saw earlier from Pedro what we could do already many years ago with ShipConstructor and AutoCAD. Let's use that. Let's do that. So all of a sudden, I'm creating an archive, which is not just an archive of drawings, but it's an archive of information. Not only data, it's information. So that's the what for. And in terms of bringing things together, I actually prepared 3 very, very simple examples that make use of all these programs. So I'm going to start by bringing up Rhino. This was the model that Stefan showed you yesterday, which he will talk again a little bit later. It's a Rhino file. It can be subdivided in many Rhino files. You don't have to stick to a single one. You can, in Rhino, you have the equivalent of the XREF. You have the work, I think it's called the workspace. So you can effectively XREF other Rhino files. Express Marine has stocks, which we use in Genesis to create ShipConstructor parts. It has stocks, which it uses to create bill of materials, quantities, center of gravities, weights. And all of this, just like Pedro was showing a little bit earlier, all of these, he was doing Excel and Automator, but we can certainly do an export here of blocks. How much is this block going to weigh in structure? More or less, because it's not a detailed model, but it's got most of the weight in it because I have all my primary and secondary structure. So I'm missing a few faceplates for the moment. I'll be missing the brackets for the moment, but then I can say that it's going to be estimated at 85, 95%. That's something that we know. Right? Now, Rhino also allows me to save in very many different ways. I can save as, I can save selected, I can save selected to different files. So even if I'm doing all the structure by myself, I don't have to give all of the ship to the AutoCAD and ShipConstructor user. I'm going to select some things and save them to a separate file. Now I can save it to a 3DM file, which is readable directly by AutoCAD, and I can save them as a DWG file. If I save it as a DWG file, this is part of what's coming, I can save solids. But already, and I'll go to ShipConstructor now, I import that model as is. This is a reading a 3DM file from inside using the AutoCAD read 3DM file command. So I split my view in AutoCAD into 3, which shows that I can still use AutoCAD. after all these years. But I wanted to show the detail, because yes, it is a surface model, but it is a realistic surface model. So I might be missing the thicknesses for the moment, because here I have read only the surface-based model from Rhino. It's not the Genesis input which gives me solids, but these are going to show me, and I'm going to be able to clash these, where to put my systems, my interior that Jose showed us yesterday, how much interior he did for this particular ship in Revit, and I'm not sure how long it took, but apparently a very, very short time. But even if it took longer, it doesn't really matter at this point. We're not talking months, we're talking hours. And these hours are not just that we're saving hours to make the interior, we're saving weeks in the overall workflow. I can start my systems on day 2 of the beginning of the project. I can start my interior design on day 0 of the beginning of the project. So the lead time to this concurrent modeling, engineering, whatever, is now shrinking very, very much. And another thing to come, I can set up my marine drafting drawings in a ShipConstructor without anything. I just set up my views from location files. I set up my views arbitrarily, wherever I want them to be. What do I connect them from? Philippa showed us earlier that in assemblies, in arrangements, in output files, etc., I have a whole variety of possibilities of picking and choosing what goes in that file. And whatever goes in that file, through the criteria of selection, which could be the branch of a product hierarchy, which could be a drawing that at the moment is empty, is going to be sectioned and put in marine drafting. And we'll get to that too in a second. So we're now doing a multiple concurrent exploitation within this collaborative workflow. Sounds fantastic. It fills your mouth when you say these big words, but in practice, it's very, very powerful. So then we can go a step further and say, right, so now I have my structure, I've done my systems, and I want to import some Rhino stuff. And I'll go back to Rhino for a minute, to another file, where I just put a cube and a cylinder, and I cut a section through the cube and a section through the cylinder. So, no rocket science here. Now, I use the Rhino command section to do that. If, like many of you can, if you're using Orca 3D, that section remains associative with the surface. I picked a solid. I made a solid because my end product wants to be a solid in ShipConstructor, but very, very straightforward Rhino commands. So once I have this, I actually saved it as a DWG, and that DWG is there. All right? Now, how did I do that? Well, what I did was I created a planner group, which I called from Rhino, just so that I wouldn't confuse it with the others. And when I save as in DWG format from Rhino, I overwrite this DWG file, this planner group. This planner group does not and will not ever contain any ShipConstructor parts. It will always and always contain only Rhino elements. And the source is indifferent. It could be Revit, it could be Inventor. In fact, when you create an Inventor assembly, which is very good at doing grillages and things of that sort, you also get fantastic fabrication drawings. Those fabrication drawings want to enter the workflow, which is managed and exploited by publisher. That is why rather go to planner groups than to AutoCAD files saved somewhere on my network. Now, because this is never going to be used by ShipConstructor, and I will never use it from ShipConstructor, I don't even need to open this file ever. I only opened it to show you what it looked like inside. And the nice thing about it is that this is a 3D solid. 3D solids are sectioned by marine drafting. So the next thing I want to do is in marine drafting, I want to combine my solids coming from Rhino, my parts coming from ShipConstructor. Let's remember that the big difference between your arrangement and your output drawings is when you select, for example, planner groups. In the output drawing, you only get the parts because the output drawing talks to the database. In an arrangement drawing, you will get what contents of that file as well, not just the parts. So two differences in when it comes to then page setting your drawing, your output, because in your arrangements and in your assemblies and in your output drawings, in all three places you can run marine drafting. And Filippa actually introduced the second part of my talk here by talking about using XREFs in marine drafting, which is far more powerful than you initially would think, because that XREF, again, can go to any AutoCAD compatible file. That's not limited to DWG files, but it can go to open a Rhino file, a SolidWorks file, or whatever else file. So this is one little strategy to use planner groups, let's call them dummy planner groups, to bring drawings and models from other sources into the enterprise platform workflow. And when I change my model in Rhino, I change my sections in Rhino. We are up here somewhere. There we go. This is just the sections that I showed you earlier. Next time I open whichever other file this is XREF'd in, it will be updated with what happened in Rhino. So now I have a live flow, which is a little bit like the M-Link refresh, but I have a live flow from other sources of information into the ShipConstructor world to go and improve and enhance and complete my drawings. This drawing I shall never open with ShipConstructor. I don't need to. I just create a planner group once, and I keep on overwriting that. To go back to solids for a minute, how am I going to get these solids into my output drawing, if that's where I want to use? If I'm using my arrangement drawings, I just pick this planner group in my list, and then those solids will come into my arrangement drawing. And when I do my marine drafting in arrangement, I get the cut of the solids. Another difference between arrangement and output: in arrangement, the marine drafting drawings stay within the same file as the arrangement drawing. In the output, the marine drafting drawings go to a separate file which XREFs the output drawing, which makes it a little bit lighter. Back to Publisher LT, I have to bring these solids into my output drawing, and easy thing to do is simply say, let's get a naming convention going so we always know what these are called for every project. And then in the operation, I'm going to say, open this file, which the operation sees as just about any other AutoCAD file, copy what is in here into my output drawing. And I do that before I go and generate my marine drafting cuts and my marine drafting drawing updates. So the mechanism becomes fully automated, and I'm now feeding my marine drafting drawings from Rhino, just by doing this little thing. So let's move on to the other project. Let's go back to the other project, which I have here, and show you something else. So this was the house building that we looked at yesterday. And this is the planner group. The way the modeling went is we modeled the bottom floor and then simply copied everything in a stack, because these apartments are identical in a stack. And that means that I can hide everything. The top 3 floors, I can hide them, keep on working on my bottom, keep on detailing it, and everything else gets updated. Now, when I am in here, let me find this, I have to find the drawing that I wanted to show. Here, this one here. I then go and say, right, I am going to create an assembly drawing. This is not a very useful assembly drawing per se, but in this assembly drawing, I XREF'd another AutoCAD drawing, and this other AutoCAD drawing is a purified plan view of the architect's drawing that came from Revit. So keep on publishing to DWG, keep on XREFing into my assembly, and I will see exactly what it is. I have another drawing that I forgot to open. I'm going to open it now. Which shows how I am going to superpose my marine drafting from the ShipConstructor model with a fully detailed, obviously as detailed as you want it to be, drawing from the, this is working on a VPN in the cloud, so it's taking a bit of time to build. I'm afraid I forgot which drawing I Sorry guys, I'm gonna have to look for it, but let me just jump to the next one. And just this morning, so I created a Navisworks file, which reads DWG files from ShipConstructor, DWG files from ShipConstructor of ships. This came from Rhino, it's a straight read from Rhino, and this came from reading the DWG file inside my project. So in here, I'm now combining everything. It's Navisworks, and we'll see what SmartShape can do also in addition to what we already know about Navisworks. But this becomes my collector. And this collector, I will have 500 of, because I will have one specific collector for every stakeholder who's interested in a particular thing. And I will have maybe a global collector, because when I go in here and select, I'm going to select this, and it doesn't have any ShipConstructor properties because it's just a solid from Rhino. I select that, it does have ShipConstructor properties. I select this, it does have ShipConstructor properties. I select that, it doesn't have ShipConstructor properties. But stuff that comes from Revit, from Inventor, and so many other sources will have its metadata. And if I wanted to, from inside Navisworks, I can now export bill of materials, list of parts, because it has an export to Excel. So now, if you bear with me for just a second, I will go find my output drawing, which is in here, and we're going to open that. I just forgot to open it before I came up here. It's going to take a minute or so to synchronize. But in here, I wanted to show the overlay of a marine drafting section of the building with the original architect's drawings from Revit in this case. The goal of the exercise being, how am I going to augment my ShipConstructor model, which is not as detailed as the architectural drawings from Revit, because when you draw a door in Revit, you get the line that shows you the opening of the door. You can draw wardrobes and things of that sort, which we will not model necessarily in ShipConstructor in the early stages. We probably will get to them at the end because they have to go into a different set of bill of materials than the one already supplied by the architect. But at the same time, in my drawing, I want my drawing to be as realistic as possible when it goes to the people in the building site or to the people on the assembly line. And therefore, I have to be able to label my ShipConstructor entities, which is what they're manipulating within the context of the overall architectural drawing, which remains a little bit of a common denominator in terms of communicating across a civil engineering or a civil building project. So we'll give it a minute. While it's doing that, I'll just mention that obviously these items were not there in the original location, but you can move them in your Navisworks environment by simply selecting either the item or even the file that it came from and apply a transform. The transform means that you're going to scale, you're going to move. So in Navisworks as well, you can create exploded views, if you may call them that. And this can also be scripted. So it's once you have the script once for the project in general, then you have it for the rest. And this is an example, therefore, that you finally loaded, where I have Xraft M-linked. This drawing, which ended up in a planner group, and I have put it in a planner group because it will be handled much more easily by publisher. So this is in a planner group. It's an Xraft, but it's in a planner group. This is a section of the bottom structure, it's called the platform, of my volume element, and I just simply went and put the labels that I wanted. These are labels from the bill of materials. This is a property label. I'm sure you already remember what a property label is. It's this label here, property labels. And this is a different property label for the pipe. This is for a piece of insulation, I think, and this is for a pipe. So at this point, I can now continue detailing my output drawings, my documents, as they come to life. I don't have to wait for them to be finished, and if something changes, if that part were to be deleted, the label would disappear. If that part were to change stock for some reason, or we're going to put a 100 millimeter drain pipe instead of a 50 millimeter drain pipe, the label would update. If I move the geometry, the label is going to follow the geometry. So the classic marine drafting functionality applied in a different way. And of course, this is an open door to just about everything and anything you care for, because I am in AutoCAD. So I can XREF what I want, I can go to different sources, and the different sources can XREF or take the DWG drawings that I may be now publishing. Filippa was very inspirational in showing how you're going to reference an arrangement drawing in a marine drafting drawing. It's all DWG. We can reference those in another software if we're using another software or for another purpose. And the same bill of materials like Pedro was showing that I have in here, regardless of the complexity and so on, those same bill of materials with that information, or perhaps more because I'm now reading the database, go to somewhere else. This is an AutoCAD file. The bill of materials is an AutoCAD table. I can read the AutoCAD table in one of my operations, read the AutoCAD table, take those numbers, do something with those numbers, push them to Excel, calculate them, bring them back, make another table. I can XREF my Excel file directly into here, and so on and so forth. So this is, just wanted to show how simple and how easy it is to exploit all of these sources of truth in the workflow that at least I gave a simple idea of. That's it from me. Thank you very much. It's my last presentation.
Thank you, Nick.